Assalamualaikum warahmatullahi wabarakatuh. First of all, I want to say it is such an honor for us to be the presenter in this international journal that organized by Borobudur International Symposium 2023. Before we start the presentation, I want to introduce about the authors here. The first author is Insinyur Gunaedy Utomo, STMT, and then the second is Dr. Insinyur Haja Andi Marini Indriani, STMT, and the third is Dinda Damayanti, ST. We are from Balikpapan University. Our research consists of 5 chapters. The first is introduction, second is literature review, the third is research methodology, third is results and discussion, and the last is conclusion. So I would like to present about our research with the title, The Effect of 0.8% Polyethylene Terephthalate Plastic Waste Substitution on the Flexural Strength on K-175 concrete. So as we know in these days that one of the types of waste that causes environmental pollution because of its large amount and difficult to recycle is polyethylene terephthalate, or as we known as PET plastic. As we can see from the chart in 2018, research by Dinda that Indonesia has been ranked as the second country in the world after China as a producer of plastic waste. As can be seen in the presentation frame, that the picture on the right is located in Balikpapan City. There are still a lot of plastic waste, especially PET plastic, that scattered in the seashore area and clusters. On the other hand, the concrete construction industry is one of the main sectors that utilize natural resources as building construction. The rapid increase in concrete construction has resulted in the depletion of natural resources or natural aggregates, so that new innovations are needed as concrete mixed materials. However, there are some local materials in East Kalimantan, Indonesia, where aggregate availability is abundant, such as coarse aggregate from Petangis and then fine aggregate from Samboja. That's why the reutilization of PET plastic waste as concrete mixture in this research is needed. As we can see that the previous research that was done by Samsudin and Hamid and Fauzi in 2023 for the title Compressive and Flexural Strength of Concrete Containing Recycled Polyethylene Terephthalate or PET. And then the results indicate that using 1% PET variation in concrete can significantly increase the flexural strength up to 9.50% compared to normal concrete. Also, the previous research that was done by Singh in 2020 for the title Partial Replacement of Cement with Polyethylene Terephthalate Fiber to study its effect on various properties of concrete, and the result, as the percentage of PET in concrete increases, the flexural strength also increases up to 19.35% compared to normal concrete. And for the methodology research in here, the materials that we are used, the first is Portland cement type 1, and then Patangis coarse aggregate, Samboja fine aggregate, and then water, and then PET plastic. The PET plastic in this research is chopped or pulped to a length of 5 cm and a width of 1 until 3 mm as a partial replacement of fine aggregate as much as 0.8%. And then also the flexural strength that we are using for the method is with 2 loading points. And for the slump value, it is between 8 cm until 10 cm. And then for the results and discussion. First, we can see that the slump test in this study is used to evaluate the workability of concrete with a value between 8 until 12 centimeters. As we can see the result in chart on the right screen, that presentation, that normal concrete has 10 centimeter and for pet concrete has 8 centimeter. Um, we all also can see that pet concrete has a smaller value than the normal concrete slump value. This is consistent with the research conducted by Gunaedy in 2021 that the addition of pet can be caused by the flat shape of pet so that it has a larger surface area compared to natural sand. As a result, there will be further friction between particles which result in reduced workability of the concrete mixture. And for the picture that already in presentation screen, we also can see that the normal concrete we have 10 centimeter for slump value, and then for the pet concrete we have 8 centimeter for slump value. Based on the data in figure 14 and 28, this flexural strength, the pet concrete has the bigger results than normal concrete. The average result for 28 days normal concrete has 3.187 MPa and pet concrete has 3.325 MPa. So that it means it increased 4.33% from normal concrete. In here, we can see by the previous research that was conducted by Damayanti et al. In 2023, the fiber properties are very influential and capable to increase the flexible strength value of the beam along with the addition of fiber in each percentage variation. Why is this happening? Because according to Azarfor, Nikoro, and Taheri in 2016, PEP itself has a flexural modulus of elasticity and a tensile strength of 2.4 GPa and 60 MPa. Um, and then by previous research that conducted with Singh in 2020, the increase in flexural strength is also due to the tensile properties of PET fiber particles, which are able to resist the tensile force. And then also, according to Colosa et al. And 2022, that the increase in the amount of plastic fibers gives an increase in the strength value because the plastic in the concrete constituent mixture is able to resist the load. So in here, we can see that the difference between normal concrete and 0.8% fat substitution concrete in the picture, that the crack pattern for normal concrete fractured into completely two separate pieces. Meanwhile, fat concrete cracks in beams are much finer and less in number compared to normal concrete failure cracks. According to previous research, this is due to the interlocking nature of the mixed cracks of the PET fibers that provide strength to the beam spacement, according to Casa and Canali in 2019. In 2019. And then also, according to Rashid et al. In 2021, that the PET concrete cracks in beams are much finer and less in number compared to normal concrete failure because the fibers strengthen the internal bonding of the concrete material part. For the conclusion, we can also say that based on the results of the research that has been carried out, it can be concluded that Mixing PET plastic into concrete can increase the value of the flexural strength of concrete, where PET concrete aged 28 days has a value of 3.325 MPa, or has increased of 4.32% from normal concrete. So we all have presented all the content of our research from chapter 1 until 5. That's all about our presentation. And if there are any questions, you can ask us in the comment section below. So we would like to say thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.